Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. So this is the last part 20 video on the subtopic of floating and sinking from the chapter of physical quantities and measurements where I will discuss about another interesting formula that I have found, I have come to know to find the relative density of a liquid based on the apparent weight of a solid in the liquid and the apparent weight of the solid in water at 4 degrees centigrade. The catch is that the density of the solid has to be more than the density of the liquid and the water at 4 degrees centigrade. If you find this video beneficial, then please like it, share it with your friends, and if you want to further support me, then please subscribe to my channel, and in that case do not forget to press the bell icon so that you will be notified by my future videos. So let's start part 20 video where I will discuss about how to find the relative density of a liquid based on the apparent weight of a solid in the liquid and in water at 4 degree centigrade. Okay, so I have just drawn the diagram. I haven't worked it out whether how we can find the relative density of a liquid based on the apparent weight of a solid in the liquid and water. So on the left hand side we are having water. So and the density of the solid has to be we can take any solid, but its density has to be more than the density of the liquid and density of water at 4 degrees centigrade. The objective is to find the relative density of the liquid. Now, since the body is denser than both the liquid and the water, in both the cases it will sink. Okay. So now on the left hand side, in both the cases, two forces will act on the body as per Archimedes Principle. The weight of the body acting vertically downwards, and the buoyant force or the up thrust acting vertically vertically upwards. Let's see now what we are given is that we are given that the apparent weight of the body in the liquid and in water at 4 degrees centigrade. Just based on these two data, we have to find the relative density of the liquid. Okay, now in the left hand on the figure in the left hand side, on the left hand side we are having the liquid is water at 4 degrees centigrade. Okay, so I know that okay, so what we are given either the Lawson weight of the solid in the liquid and water or the apparent weight. Let's say we are given the apparent weight. So the apparent weight we know is W dash is equal to W minus FB. Okay, so this is the apparent weight. So we are given W dash. Okay, we are given the apparent weight W dash. Okay, so the idea is that how do we what will be the relative density of the liquid? It will be the mass of certain volume of the liquid divided by mass of the same volume of water at 4 degrees centigrade, and we will consider the volume of the solid to be that volume. Okay. Okay. Let's say for the liquid on the right hand side, I am considering W double dash to be the apparent weight of the body in the liquid. So this will be W, and on the right hand side, please notice that the upthrust on the body is FB dash. So this is FB, W minus FB dash. FB dash is the upthrust acting on the body when it is inside the liquid, and the liquid is having density rho 2. Okay, we are given W dash and W double dash. From these two data, how do we find the relative density of the liquid? Okay, now consider what will be the mass in both the cases. What will be the for water? What will be on the left hand side? What will be the mass of the water of volume V where V is the volume of the solid. We know W dash. Okay, so W dash FB will be, as I have discussed in the previous video, FB we know will be V, that is the mass of the displaced liquid, which will be volume of the displaced liquid multiplied by the density of the displaced liquid. In this case, the liquid the density is Pw, which is 1 gram per centimeter cube. So this will be V rho W. This much gram force will be the upthrust on the body when it is in the water at 4 degrees centigrade. Okay, and FB dash, that is the upthrust when the body is in the liquid, this will be again V rho 2, this much gram force. Okay, so okay. Okay, so it is not so what information we need to find the relative density of the liquid? I think we need either the loss in weight of the body in both the liquid and water at 4 degrees centigrade, or the apparent the weight of the body in air, and the apparent weight of the body in the liquid and in water at 4 degrees centigrade. Okay, now so definitely we can say that mass of VML, I'm considering a CGS unit. So if let's say the volume of the body is VML, so mass of, we can say mass of VML of water at 4 degrees centigrade is clearly V rho W, which is coming out to be FB, which is the upthrust acting on the body when it is in water, and this is nothing but the apparent weight of the body in water minus the weight of the body in air. Okay, now the same thing for the liquid. We can say mass of VML of liquid, that is having a density rho 2, is equal to V rho 2, actually V rho 2 gram, and also mass of VML of water is V rho W gram. So this is also equal to F dash FB dash, and which is equal to W minus W double dash. So we can say that the relative density of liquid, we can say from the alternative formula, mass of VML of liquid divided by mass of VML of water at 4 degree centigrade, and mass of VML of liquid is W minus W double dash, and mass of VML of water at 4 degree centigrade is W if B is equal to W minus W dash, sorry, this will be W minus W dash. So this is W minus W dash. So this is the, you can see that if we are given, if we know W, that is the weight of a body in the air, and if we know W dash, that is the apparent weight of the body in water at 4 degrees centigrade, and we know the apparent weight of the body in the liquid, then we can find the relative density of the liquid. Now what is W? Now this is again equal to FB dash divided by FB. So this is the basically the formula. Liquid RD, the relative density of a liquid can be found as, now what is FB dash? FB dash is nothing but the loss of weight, the loss in weight of a body when it is in the liquid, which is equal to the upthrust on the body. Remember that we are considering a body whose density is more than the density of water at 4 degrees centigrade as well as the liquid. So the relative density of the liquid is coming out to be the apparent weight of the body in the liquid divided by the apparent weight of the body in water, or the loss in weight actually the relative density of the liquid is coming out to be the loss in weight of the body in the liquid divided by the loss in weight of the body at water at 4 degrees centigrade, which is equal to W minus W double dash, that is the weight of the body in air minus weight of the apparent weight of the body in the liquid divided by weight of the body in air minus apparent weight of the body in water. So this is another interesting formula using which you can find the relative density of a liquid. I hope I was able to explain the fact that how we can find the relative density of a liquid using some solid body which is denser than both the liquid and water at 4 degrees centigrade, and from the data of apparent weight, the weight of the body, solid body, its apparent weight in the liquid and water, or just the loss in weight of the body in the liquid and water, we can find the relative density of the liquid. So if this video was beneficial, please like it, share it with your friends, and once again, please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. I will try to solve 3 or 4 problems based on this video and the previous video, where I discussed how to find the relative density of a solid based on its apparent weight, its weight in air, apparent weight in water at 4 degrees centigrade, or its loss in weight in water at 4 degrees centigrade, and also how to find the relative density of a liquid based on the apparent weight of a solid in the liquid and water. Based on these two, based on the video part 19 and 20, I will try to frame some few 3 or 4 questions and solve them. It will give you a better clarity of how to apply the concept. That is all for this video. Thanks for watching, and until the next video, take care and bye.